Here we have a question. The boat is moving this in this direction and the flow of water is also in this direction and air is blowing from this direction. That means air is blowing from perpendicular direction from the direction of the water. Okay. So what is the velocity? What is the velocity of boat with respect to the ground? That the velocity which we can observe from the ground. What is the velocity of the boat which can be observed from the ground? So here it is. This velocity VBW is velocity of boat with respect to the water. That means the velocity of boat in still water is 20 km per hour and in this direction along this direction. Okay, and water starts flowing in this direction and that is flowing with the velocity of 5 km per hour. So VWG is velocity of water as observed from the ground. Okay, now the air starts flowing from this direction. That means 90 degree from the flow of the water, that direction of the flow of the water. So and the velocity of the air is as observed from the ground is 10 km per hour. Now we have to find that what is the velocity of the boat from the as observed from the ground. Okay, so let's first find velocity of the boat as observed from the ground when there is no air. Okay, so velocity of boat with respect to the ground when no air is there. Okay, no air case. So how could we do that? So velocity of boat with respect to the ground should be velocity of boat with respect to the water plus velocity of water with respect to the ground. Okay, this is the formula for this question. Okay, so let's find out what it will be. Since the direction is the same, VBW and VWG has same direction, we can add them directly. So the magnitude of VBG will be equal to the magnitude of VBW. That means the velocity of boat with respect to the water is 20 km per hour plus velocity of water with respect to the ground is 5 km per hour, and this comes to be 25 km per hour. So velocity of boat with respect to the ground when no air is 25 km per hour, and the direction is VBG is equal to 25 km per hour, and the direction is this direction. Okay, now what we will do, we will find when air starts blowing with air. Okay, so with air VBG, what will happen? Velocity of boat with respect to the ground is this, and velocity of boat when air starts blowing, so the final velocity must be VBG. Okay, that we have find out that with no air we are putting here plus the velocity of air VAG. Okay, so the direction of this velocity is this direction, direction of this velocity is that direction. Okay, so we have to add this as triangle law of addition. We will apply triangle law of addition. How do we do that? We will draw them. This is 25 km per hour and this is VBG. Okay, and the next one is VAG, and that is equal to VAG. How much is it? Is 10 km. Okay, now the final velocity must be the end of this point should go to the end of this point. Now the length of this arrow, this direction, is the final velocity. So what it will be, this is 90 degree, so we can use Pythagoras theorem, and that is this velocity will be 25 square plus 10 square and the square root of that. Okay, so the final velocity will be this expression, and what this angle should be, theta. So the theta must be the solution of this equation. Okay, that means 10 divided by 25, 10 divided by 25. Okay, that means perpendicular divided by base tan theta. So the angle is this. How can we write this? Theta equal to tan inverse 10 divided by 25. That is theta and that is VB with air. Okay, so this is how we solve this problem.